Hi everyone, so this is the second part for week number 2 for image processing, computer vision and image processing. So the idea here, we were talking about image representations and we stopped when we talked about how to represent an image as an array, a numerical array. As you can see here, this is our origin 0, 0 and this is f of m minus 1, f of n minus 1. These are the rows and these are the columns which represent the image over here. Furthermore, how do we represent these images? If you see here, this is the origin, which is 0, 0. This is row number 1, column number 0. Here, row number 1, column 0. Here, row number 1, column 2. Row number 2, column number 0, and so on. This pixel over here, for instance, this pixel will be considered as row number 2, column number 2, and so on. We are using the floor function to get the center of an image. We go for floor m by 2, n by 2. Floor is rounding down the image. Floor is rounding down the image. If you recall, we studied this in C++ where we talked about floor and ceiling in images. So each value of an image is called a picture element or a pixel or a pill, but we are going to consider it as a pixel. So this shows that the x and y values will contain pixels, and these pixels are represented as functions in the array over here, f of x and y. So image digitalizations require the decision are made regarding the m and n and the number of L discrete intensity level. So we have m and n. Once more, this is an image. It is m by n, where m is the number of rows, n is the number of columns. Okay, the third part is L. What is the value I'm going to put here? Okay, what is the value I'm going to put here? Is it a black and white, 0 or 1? Is it a colored image with 8 bits from 0 to 255? Is it a 10-bit image from 0 to 1023? So it depends. So we have three values. M and N will tell us how many pixels within our image. L will tell us how many levels of colors or intensities that we have. So we are going to talk about this in this section over here. So the L, if we say L is equal to 3, then we have 8 levels. If we say L is equal to 8, then we have 256 levels, and so on. So L is an integer that defines the quantization levels. L is an integer that defines the quantization levels, and remember, this is the integers are, we assume that the discrete levels are equally spaced and they are integers of the range between 0 and L minus 1. Now, some of the ranges values span in by the grayscale refer to the dynamic range. Okay, we have something called the dynamic range. If you heard about it, a term used in different ways in different fields. So what is dynamic range? Dynamic range, if you hear people talking about an image, they say this image has a wide dynamic range. So the dynamic range is the ratio between the maximum measurable intensity and the minimum detectable intensity. The ratio of the maximum measurable density to the minimum detectable density. So if you have a high or the dynamic range is high, this means your intensities are spread very wide in the range. As you can see here, the image, if you have n is equal to 1, your intensity will be low. If you have k is equal to 8, then your intensities are high. So the dynamic range establishes the lowest and the highest intensity levels of a system, closely associated with the concept of image contrast. image contrast. Contrast in Arabic اللي هو التباين. تباين. So if you have high contrast, this means your blacks and whites are widespread between each other. Low contrast, this means they are close to each other and everything is between these range. So we try always to spread the contrast and to have higher range. So image contrast is defined as the difference in intensities between the highest and the lowest levels. Here it is difference, and here it is the ratio. Ratio, division, difference, subtraction. So the contrast is the ratio, the contrast ratio is the ratio of those two quantities. When an applicable number of pixels an image have high dynamic range, we can say it has high contrast. And these two values are connected together. If you have high contrast, this means you are going to have high dynamic range. So the number B always is the number of bits stored in an image. So B is usually called M multiplied by N multiplied by K. M multiplied by N multiplied by K. Now we are going to talk about spatial resolution. We have two types of resolutions. One of them is spatial resolution. Basically, spatial resolution is the number of pixels per unit of distance. So suppose that we are constructing a character with alternating black and white vertical lines. So I'm having black and white lines in a unit width W, which is W can be less than 1. The width of the line pairs 2W, and there are W 2 lines per unit of distance. For instance, if my width is 0.1, then there are 5 pairs. 0.1 plus 0.1 is 0.2 multiplied by 5. This will give you 5 pairs per unit of distance. A widely used definition is image resolution is the large number of discernible lines per unit of distance. يعني if you have high resolution, this means you can have more lines. As you zoom in, you are going to see more and more lines inside your image. Keep zooming in, you are going to find more and more lines in the image. Another way is the dots per unit of distance, or what we call DPI. Now DPI is short for dots per inch. Yes, we are not using the US metrics, but DPI, if you go and buy a printer, it will tell you, let's say it has 50 DPI. 50 DPI, it means it has dots, 50 dots per inch. Okay, 50 dots per inch. The higher the DPI, the better your resolution. So for instance, the resolution of a newspaper is 75 DPI. A magazine will have 133 DPI. A glossy brochure will have 170 DPI. A book will have around 2400 DPIs. طبعا high resolution book. So DPI is the number of dots per image. The spatial resolution is a meaningful measure. However, it's not always easy. So if I tell you I have a resolution of 124 by 124, this is meaningless unless I say what is the distance I measured in. If I say 124 by 124 per inch, this is meaningful. If I say 124 by 124, it does not mean anything unless you specify the spatial dimensions. That's why it's called spatial resolution, because you need to specify the space that it takes for that resolution. On the other hand, if I say that I have a camera which is 20 megapixels CCD and another camera is 8 megapixels, assuming both cameras are equipped with compatible lenses, the images sorry, the comparison of the images are taken of the same distance, then we can say that this image, an image with 20 megapixels is better than an image with 8 megapixels. So you need to make sure that all the conditions are right, then you can go and compare between these values. So this is an example. This is an image with 930 dpi. This one is 300 dpi's. Again here 150 and 75. You can see here, you can see the details how compared here. Here you cannot read the number. Here you can easily see the 60. You start fading the 60. 60 is not noticeable over here. All the details will be lost as you go with lower DPI. Then we have intensity resolution. Intensity resolution is how many levels are you going to give inside the image. If I go back a little bit, when we were talking about the images, we said that the image is an M by N, which is the spatial resolution, and we have the, where was it? This one, and here we have the intensity resolution. Higher intensity means you are going to have more colors or more values for the colors in your image. The most common number is, of course, 8 bits, 16 bits, some applications. Nowadays you can buy phones with 10-bit color resolution or 12-bit color resolution. Just to keep things in mind, if I have a phone that is having 8 bits, that's 255 colors, sorry, 255 colors for red, 255 colors for green, and 255 colors for red, green, and blue. So if you multiply all of these are the possibilities of the colors that you have for your image. Okay, so here are some examples. You can see here we are using 256 levels. Here we are using 128. You cannot start seeing the distance, the difference, but over here you can start see that we are losing some information. If we come here, this is 64. See, we are losing some information. Here is 32. If we go here, this is 16 levels, this is 8 levels, this is 4 levels, and this is 2 levels. 2 levels means black and white. 4 levels means 4 colors only. 8 levels means 8 colors. This is 16 colors. This is 256 colors. So this resolution is quite important when it comes to the number of colors on your screen. So you need more colors. This means you need more intensity resolution. You need more pixels. This means you need more spatial resolutions. The two are combined together in this slide over here. If you can see the image of this girl over here, this image is considered having low spatial and intensity resolution. This one is having medium, and this one is having high intensity and spatial resolution. These comparisons are shown over here. Okay, this is the NK plane, which is the isosphere curves. You can see that the face over here, the face of the girl, this is the curve for the face of the girl. Here, this is the crowd. It has more and more information. And here is the camera man over here. So each point in the AK plane represents an image having the value of k and n equal to the coordinates of the points. Points lying in the isospheric curve corresponds to the image equals subjective quantity. It was found that in the course of the experiment that the isospheric curves tend to shift to the right upwards. Okay, as we go less, it will go shift upwards. If you have an image that is something like this, then you are going to have an image with very high intensity resolution and spatial resolution. This is all for this part. I'm going to discuss more in the live discussions. Thank you for watching. Hope to see you all soon.